Hello everyone, welcome back to my channel, your go-to destination for unraveling the mysteries of cutting-edge technologies on Google Cloud. I am Mustafa, and today we will continue our journey into the heart of Google's Bigtable, the fully managed, scalable, NoSQL powerhouse. Google Bigtable is your go-to solution for handling large volumes of data seamlessly. It is perfect for storing information in a key value format. Bigtable caters for various needs, including personalization, ad text, financial media, digital media, and the Internet of Things. It boasts high read and write throughput with low latency, ensuring swift access to vast datasets for processing and analytics. It is specifically tailored for streaming data from sensors. Bigtable shines in managing high writes, capturing extensive real-time data effortlessly. In this hand-on solution, you will be using straightforward commands to set up a Bigtable instance. We would focus on creating a table designed to store simulated traffic sensor data. Following that, we would kick off a Dataflow pipeline to smoothly load simulated streaming data from PubSub directly into Bigtable. While the Dataflow job is at work, diligently transferring streaming data into Bigtable, you would have the chance to ensure that your table is getting successfully filled with the simulated traffic sensor information. The lab concludes with you stopping the streaming job and responsibly deleting the Bigtable data. So whether you are a beginner or a seasoned tech explorer, join us in this practical exploration of Bigtable's capability. Don't forget to hit the like button, subscribe, and ring that notification bell as we dive into the fascinating world of managing streaming data with Bigtable. Let's get started. As usual, we'll start our lab by clicking on Start Lab. After starting our lab, we'll open this lab in an incognito window. Then grab your password along with you. So you click on Next. Paste your password into the prompt. Then I understand. So you can see it setting up our dashboard, and here's the home page of our console. This is our dashboard. You can view the activities, the recommendation. Yeah, so before that, agree to the terms and service. So here we are, this is our home page, and we can now get started with solving this lab. The objective for this lab, we are going to create a Bigtable instance using the Google Cloud CLI commands. After that, we'll create a Bigtable table with column families using the Cloud Bigtable CLI. These two things have been discussed before in the previous labs in this playlist, particularly under designing and querying Bigtable schema. So thereafter, we'll launch a Dataflow pipeline to read streaming data from PubSub and write into Bigtable. After that, we'll verify the streaming data is loaded into Bigtable. Then finally, we'll delete a Bigtable table and a Bigtable instance using the required commands. So the prerequisite, like I said, take a look at the first video of this playlist where we went over designing and querying Bigtable schemas. So let's get started. As usual, we'll go back to our lab, then we'll activate the Cloud Shell. So I would activate our Cloud Shell. We'll run a command to list our active account ID and also the project we are on. So I can just grab this command from here. Then I click on continue, authenticate my Cloud Shell. So while my Cloud Shell is authenticating, we would be required to, it would provision our Cloud Shell machine, and after that it would connect to our Cloud Shell instance. So here we are, paste the first command. So this will tell us authorize this. So this will tell us our active account name here, and this is the active account name. And we can also run the second name, the second command, which is the cloud config list project. So yeah, and this is the project ID that we are using. So that's pretty much it for the setup and requirements. So let's dive into the first task. For task one, we want to create a Bigtable instance and table using the command line. So these are things that we've done before, and I wouldn't really dwell much time on it. We'll be using the CLI. So what this command is doing is gcloud Bigtable. That's the command for Bigtable. Then we want to create an instance, so we'll set the instance, then create. So San Diego is the name for our Bigtable instance in this case. So the display name for this instance is San Diego traffic sensors. And the cluster type that we are using, the storage type, is SSD. And the cluster config ID that we would set, San Diego traffic sensor C1. Then the zone we are using is US is 5B, and the amount of nodes that we want here is just 1. So there are some values here that you may not necessarily set, and your instance will get created. They will just use the default configurations. So, and this is, you can also create it using the console by just inputting all these things. So we've gone over this before, and you can always see that in the first video for this playlist. So let's paste this command in here, and you'd see that our Bigtable instance should get created. I would navigate to our console to also view the instance. So our instance is created. We can take a look at our instance under database. So this database, let's click on Bigtable. And yeah, so this is it. And you can see the instance we created, San Diego. So you can click on it and you'd see some other details in there. So the instance, this is the one that we use as the display name. And when you look at the cluster ID, we have the cluster ID here, the one we specified in the command. So that's pretty much it. For the next task, let's configure the Bigtable CLI. We've also done something similar in the previous lab. So why we configure the Bigtable CLI is because we want to template some values that I would be using inside the .cbtrc file, so that anytime we need them, we can just call them from there. So the two values we are templating here is our project. So that is going to retrieve our project ID, which we can get from this command, and also with templates the name of our instance, the instance that we are interested in. So the instance we are interested in here is San Diego. For a production project, you can have multiple instances. So you can easily just specify the instance you're actually interested in at this particular time. So this is the one I'm interested in. And after that, I would call a command to retrieve to read the data in this particular directory, so that I can just see what's there. So let's copy the command. Paste the first one here. And you can see that it's setting it for us. So copy up the second command also. So after that, we can decide to read what is there, so that we can be sure that it has actually templated those values. And you can see, so it's retrieved our project name here, and also the name of our instance under instance. So we are good to go. The next thing is to create a Bigtable table with column families. So we've explained that column families help in retrieving data in similar columns. So we would set a column family, and the name of our column family here. So this is what we are doing: CBT create table, then current condition. So we'll first create a new table, name current condition. After we've created a new table, name current condition, we would now set a family. So the name of the column family here is going to be called lane, and that's it. So we already have our instance. Now we are creating a table, and we are creating a column family for that table. So go back to our command line, paste this command here, click on enter, and that has been done. So we can also see that in here by just refreshing on this one. So this is what we are going to do. Just go back to our all instance pack. Then we can go back into this one, and this is the cluster ID that we have here. So we can click on tables. So after clicking on table, this is the name of the table that we just created, current condition. And to view the column family, when you just hover on this edit sign, we click on it, you'd see the current family, the column family. So the name of the column family here is lane, the one we just created. Here, and everything we've done, we can also do it on, we can do it using the console, but we've also done that in the first lab, and you can see how to do that there. Yeah, so let's keep going. Let's check our progress. And our progress is complete for task 1. So let's move to task 2. Task 2 is to simulate streaming traffic sensor data into PubSub. So we want to simulate a streaming traffic sensor data into PubSub. So we already have a virtual machine that has been created for us as part of the initialization of this lab. And there are some things in those virtual machines already that would just explore. So the first thing is to let's SSH into our virtual machine. So we'd go back to our console. By using here, you would go to Compute Engine, under Compute Engine Virtual Machines. So it's loading our virtual machine for us, and this is the information of our virtual machine. We have the training VM, so we can SSH into it, and it's going to transfer the necessary SSH keys to our virtual machine and allow us to get connected. So you can just leave this error is fine, or this notification. Yeah, so we are in our virtual machine with SSH into that. So the first thing we want to do is let's list some of the contents of these directories that are in here at the moment. So just paste this here. And we can see some directories that are here. We have the bqmagic.sh, the project environment.sh, the sensor magic.sh. So we are not really interested in this bq_magic.sh. It's not required for this lab. We would probably use it in some other labs. So let's explore what's in here. So bq is just short form for bquery, but we are not doing that here. So to view what it's in any of this directory, let's view it by using this command. So we'll check the training dataset, then under that project. So to view the one for project, you can just say project _m.sh, and you'd view the, so these are just what this is basically doing is just retrieving our project ID so that we can use it in the configurations when we are running the scripts. So that's part of it. So to cancel out of this, just do Ctrl X. So this is not part of the lab. I'm just showing you this so that you can be aware of what are inside these codes that we are using. So let's also view what's under sensor_magic. So I'll just show you now, then I'll explain later along the line, because we would also talk about that later. So we have this here, and this is typically what it does. And I can even also go over what we are doing here. So these are just some templated user commands if you are going to be running the commands all on your own. But the major thing we'll be doing here is we'll be using a GSU2 copy command to copy data from this particular directory into this particular directory. So this directory is a public data set on Google Cloud Storage. Would be copying into this directory, and after that would cd into the directory, and after we cd into this directory, we'll run this Python command. I'll tell you what this Python command does later. So let's also cancel out of this. We'll probably come back there. So that's about that. So for the next thing is to run a script to simulate the streaming data. So while at that, the first thing we want to do is we'll clone the repository that the codes are on, the command that we'll be using that are on. We'll clone this repository into our terminal. So paste this command here. And as you know, if you want to view this repository, you can just view this repository by using HTTPS, by copying this path to be able to view the repository. So I have the repo open also on my hand. I'll just wait for the cloning to get done before I show you some of the things in the repo. Yes, so our repo has been successfully cloned. So let's take a sneak peek at this. So this is the directory. If you just paste this command, then you would navigate this particular part. You see this training dataset. Under the training dataset, click on courses, streaming, process, then San Diego. So these are some of the things that are here. But the part that we necessarily just clone, we just clone the directory training data analyst. So this is the part that we have actually, this training data analyst. That's the part that I would clone. Then from there would be seeding into the necessary directories that we have. So this is the repo that we are really interested in. We just cloned everything in this particular repo at this time. So that's about that. So the next thing is to set up the required environmental variables. You can recall that when I explored what was in the project underscore env, I showed you the commands in there, and I just explained that what the script basically does is that it sets this dev shell command and the bucket environment variable. We don't have to manually set these variables into our project ID and cloud storage buckets. So let's copy this command, and we can this command will run the scripts, and it has done that. So the next thing we want to do is would start the streaming data simulator. So it also tells us that a cloud storage bucket has been created for us when we are initializing the lab, just as this virtual machine has been created for us. So we can take a look at that under the cloud storage under bucket to see that. So that's not necessarily what we have to do at the moment, because I suppose it's empty, but you can take a look at it. So from the navigation menu, you have your cloud storage under buckets. You would notice that a bucket has been created for us previously. So let's wait for it to load. And this is the bucket that has been created, and it's used the name of our project ID in creating the bucket. And also note that your bucket name has to be unique. So there's nothing in this bucket at this moment, and we don't actually need to put anything there for now. So here we are. The next thing I want to do is let's start the streaming data simulator with this command. So /training then /sensor.magic. So this is where I would explain the process that's going on here. So let's go back to our SSH terminal, then paste this command, then strike on enter. So it's going to start copying the commands that are going on there. And while this command is also working, we cannot like close out of this terminal at this moment. So if you take a look at the instruction here, it's telling us that the script reads sample data from a CSV file and publish it to PubSub. So the script will send 1 hour of data in 1 minute. So that's about that. But what we just have to do is let's continue with the task. So let's check our progress. Our progress is also complete for here. So at this stage, I would go back to a particular directory and explain what the code does. So for task 3, we want to launch a Dataflow pipeline to write data from PubSub into Bigtable. So the first thing we want to do is we cannot use the same terminal again, because the terminal is actually working, and we don't want to terminate the streaming process ongoing here. So what we are going to do is under our terminal setting, under new connection, you can click on new connection. It's going to also create a new terminal connection for us. So that's the same process. It will transfer the required SSH keys to the virtual machine. Let's wait for it to get transferred. Then it's establishing the connection to SSH server. Yeah, so here we are also on our terminal. So I can just look at the previous one here and copy this command once again. So let's just copy this command once again. Yeah. So I'm here. This is not necessary, but because I want to show you what's going on here. So like I explained, we are copying data from a publicly accessible cloud storage bucket. So this is the part in that particular bucket, and we are saving it in this folder. So we are downloading it with PubSub, and after that we'll seed into this particular directory. So typically what PubSub does is he publish messages to and there will be a subscriber that would now like be receiving those messages that PubSub is publishing. So PubSub is just publish and subscribe. So it's a messaging platform, a messaging, publishing, and subscribing platform. So yeah, going over this, that at this particular place. So this command also copies this command into the required path, and after that would seed into this directory. So the part of it saying this script sends a 1 hour, it send a 1 hour worth of data in 1 minute. So this is the particular part, and what the Python command is typically doing is that it just simulate the sending process, and it will execute this send underscore sensor underscore data.py file, and it's also passing a parameter, so which is the speed factor of 60, and we are setting the project configuration to be our project ID. So that there's a send underscore sensor underscore data.py file that's somewhere in this direction. So we can cancel out of this by using Control X. So we are out of our nano at this particular moment. So the next thing we want to do is let's run that particular script once again, the one for the source, so that we can also set our environmental variables in this new terminal shell that we opened. Yeah, so we have here, we've done that. And after that, we can launch the Dataflow pipeline. So launch the Dataflow pipeline, we have to first cd into the directory of the Dataflow pipeline. You remember that we already cloned our repository into our terminal, so we just have to cd into that particular directory. So you can also go through this format by navigating from training data analyst to courses, trimming, process, then San Diego. So what's going to happen here is we have courses. Then after clicking on courses, we can look for the streaming directory. This is the streaming directory. So after this, getting the streaming directory, then we can click on process. Then this is San Diego. So this is the directory that we are seeding into at the moment. So let's keep doing what we are doing. So let's copy our command here. And now we are in this particular directory. So following the lab instruction, the next thing we want to do is we can review the script using Nano. So we want to initiate the run on cloud.sh. I'll show you what's on this particular directory at the moment. So let's go back to our run this, strike on enter. So this is just the commands that get initiated to run all these scripts. And what this is doing, that this script is just a convenient way to run Java application using Maven and Google Cloud Dataflow. So it provide flexibility through command lines argument for specifying project details, configurations, and optional parameters. So you can see that we are using flexible configuration details here. So here we have our project. So we are templating all these values, and they are going to get slotted by that environmental by the project environment that we already initiated previously. So that's typically much it. So export the required path, and thereafter we display the information. So that's really about what this code does, and it's also setting an optional parameter here whereby you can extend the number of nodes if you get an error, but hopefully we don't run into quota problem. So just a recap of what this is doing. So there's a command line argument check that's checking the command line argument here, and after that we are passing the command line argument in this particular part. So that's typically what we are doing. Then we can close out of this by doing Control X. Yeah, so we are outside. So the next thing we want to do is to launch the Dataflow pipeline to read from PubSub and write into Bigtable. So in there, so using this same configuration file, would run this part, and we've set our table. Don't forget that the table name we created on Bigtable was current condition. So, and we are using the bucket. So it's what's going to do is that the Dataflow pipeline is going to read from PubSub and write into Bigtable. But in between the process, there's going to be something. So the Dataflow pipeline, when it's collect the message from PubSub, it's going to like put it temporarily in the cloud storage bucket before it's now take it to Bigtable. So let's copy this command, and that's why we are having this here. And that's also why we also like configured our bucket creation. So paste this command here, strike on enter. So it's launching the Dataflow pipeline and it's going to start reading our message from pops up. So if you are not familiar with Dataflow has some templates that can help you move data from different places. And what the template we are actually using here is just from pops up to Bigtable. So we are moving data from pops up to Bigtable. That's typically what's going here. So the template that we are using. And don't forget that we already simulated our data for the sensor going on in this previous terminal, so it's still ongoing. So let's wait for Dataflow to get initialized and this particular thing. While that is going on, we can take a look at the repo that we checked. So under this repo, it does what this pom.xml file. So the overview of it is that it's a Maven project for a Java application using the Apache Beam framework for streaming and batch processing. And what this code includes, it includes the dependencies that we'll use, the build configurations. So if you look at this, you'd see the dependencies, you see the repo part, you see the properties part, you see the build configurations part, and other settings that are just actually needed for the Dataflow job to run. So you can check more about how Dataflow works on how Dataflow works. So Dataflow is a managed platform for Apache Beam by Google Cloud. So there are different managed platforms for Apache Beam on different cloud provider also, but that's the one for Google Cloud. And to use Google Cloud, you just specify the runner to Google Cloud. Yeah, so that's fine. Let's explore the Dataflow pipeline. And to a Dataflow pipeline, we'll come here under this part. So let's navigate to Dataflow once again. You click on the navigation menu. So you have Dataflow under analytics. So analytics is a little bit downward. Yeah, so under analytics, we have Dataflow here. So let's view the job that got created from that particular command. Yeah, so this is the Dataflow job that got created, and we can click on it. Let's explore what's inside the job. Yeah, so it's loading for us, and these are like the processes that are ongoing. So it gets the message, it extracts the data, so it do a mutation, which is like processing. It's converted to a BQ. There's also a part of write to the CBT, and there's also part of BigQuery right here. So we are interested in this write CBT. If you click on it, you'd see the in process that are going there. So we have the Bigtable IO and the result, and you can view some things here if you click this guy. So to show some step info, and you can just take a look at what's going here and how it's running. So that's about the Dataflow job at the moment, and everything here actually is what has been coded in this particular part. So the properties, the transformation pattern that we want, and everything there. Yeah, so that's about that. Okay, so let's see our progress. Yeah, our progress is also complete. Yeah, the next thing we want to do is we want to verify that the streaming data is actually loaded into Bigtable. And to verify that, the first thing I want to do is that I would like us to first take a look at the data that got moved into Bigtable. So let's see the data that got moved into Bigtable. And when I was explaining before, and if you take a look at the previous let's see if there's a command here. Yes, so this is what I'm going to do. I would open this sensor.magic file once again. Okay, so if we go back to our SSH here. So I'm just trying to look at the previous command I used. Yeah, so this is it. So under here, what we are doing here is the GSP1055 copy. So like we said, we are copying from this particular part into this particular part. So to view the data in this part, like I said, that it's a publicly accessible data. So you can just copy it here. And when you copy the part, you would go to the command line. So to view a publicly accessible data in a bucket, what you just do is that you would include this prefix. So the prefix here is https dot dot then slash slash. We have the storage.googleapis.com. Then you put the path into that particular external data along with the extension. So the cloud training demos is the name of the bucket. So this is the name of the parent folder, and inside this folder we have sensor underscore obs 2008.csv.gz file. And if you click on enter, it's going to download it for you. So I'm just going to initiate the download and stop. So when you click on enter, you can see it starts downloading this for me. Then I've actually downloaded this thing before, and I can just open it here. So if you take a look at my file here, you can see it here, and this is the sensor obs.csv. And so it's actually a large amount of data set, so that it's around like 8 million. And like we said, Bigtable works for large amount of data set, and it do it seamlessly. So these are just data, and let's navigate to the first column. So why I'm showing this data is that when we are actually reading the data from Bigtable, so that it would look familiar a little bit. So what's in here is the timestamp, the latitude, the longitude, the freeway ID, the freeway directory, then the lane and the speed. So that's about that. And take a look. Don't forget that we created a column family called lane in our Bigtable table called current conditions. So that's about that. Going back here, so let's go back to where we are. This is the next task that we are about to do. We want to verify streaming data loaded into Bigtable. So the first thing we want to do is that let's attempt to read from our Bigtable table, and let's see if the data resides in there. So I'll copy this guy. After copying this guy, I'll cancel out of this nano by using my Ctrl X as usual. Then to view this particular part, we would go to our cloud shell. So when we are interacting with our Bigtable, we interact from the cloud shell and not from the terminals, not from the virtual machine that was created for us. So paste this command here, and we've used this command also in our 2 previous videos for this playlist, whereby what this means is that this is the data that this is the command that we used to read information in a table or data in a tables. So cbt read, then the name of the table, which is current condition. Then we are passing in a count. So we are doing a count of, we want it to just return 5 rows for us, and we are also specifying the column that we want it to retrieve from, which is lane, and we are doing a wildcard, so it should just return everything inside a particular column family. Yeah, so click on enter here, and here we are. So these are just 5 records that have been returned for us. So we have 1, the second one, the third one, the fourth one, and the fifth one. So what this is doing is that this particular part here is the row key that was used in creating the Bigtable instance. So in creating the Bigtable table, so we have the lane. So this lane is this lane is the column family. So you can see that it's repetitive lane. So these are the column families. But inside those column families, there are columns, different columns. So we have direction, highway, latitude, longitude, sensor ID, speed, timestamp. And that's also similar to what we have in this data that we showed here. So we have the timestamp, longitude, latitude, freeway ID, freeway directory, the lane, and the speed. So everything went into the lane column family that we created for all the columns here. Yeah, so that's regarding that. Yes, so the next thing we want to do is, we are pretty much done with seeing the streaming data, and we've actually seen that it works. So the next thing we want to do is stop the streaming job and delete our Bigtable data. So just a little house cleaning. But of course, if you are doing this in a production wise, then you've typically loaded your data here and you are good to go. So to stop the streaming job, the first thing we want to do is we'll go back to our terminal, the terminal that we left open. That's this first terminal. Then we'll do Control C. So Control C is going to terminate or just abort this process, and it's not going to be streamed in again. Yeah, that's about that. The next thing we would also do is we'll stop our Dataflow job. So we've stopped the process that is simulating the streaming data. So there's actually nothing for data flows to even keep moving unless there are still like data that are left to be published by the PubSub service. So to stop the data flow job, navigate to our data flow, and this is our data flow here. And what we can just do here is stop. So click on stop, then we'll cancel. So it would immediately stop the job and abort all the data ingestion and processing. So let's stop this job. Yes, so we are stopping our job, and it may take a while for our job to get stopped. So it's showing stop here, and you can see it's still canceling until the status is showed, so that's either cancelled or stopped. So you can keep refreshing this part to just know the updated status here, but still canceling at the moment. So just fast forward this and see at the end. Yeah, and now we have the status cancelled. So sometimes you can just keep refreshing at different intervals to have the updated status in real time. So our job is cancelled, and that's about that. So let's go back to the instruction. Then the next thing we want to do also, so what we are doing actually, we are just trying to clean everything that we've done. So you can recollect that we created a Bigtable table and instance. So we would also delete that here. So the commands that I showed you in that particular directory, this directory here, all this command here, we can actually use this one to delete this instance, but I'm not going to use that. I'm just going to use this the one that I'm copying on our command line. So yeah, I'm just going to come back here, paste this here. So what this is going to do is that cbt delete table. So the name of the table is current condition, and when you delete the table, everything is gone. So another thing you can also do is, you can delete the instance. If you delete the instance, then it will delete all the table in that particular instance. So you should be careful of deleting the instance first. It's better to just delete the table that you're interested in, and just delete it and go to the next thing. So after deleting the table, we can now delete the instance. So the instance we created is San Diego, like you recollect. So paste that in here also. Let's paste that in here, then strike on enter. So it's giving us a prompt if we actually want to delete that. Yes, so I'm putting in a yes, and it should get deleted. So it may take a while for it to get deleted, but we can also take a look at it under Bigtable. So Bigtable is under databases. So we have Bigtable here. Let's see. Yeah, so it has actually even deleted everything for us. So you can see we do not have any instance to display here. And previously we had the San Diego instance, and inside that San Diego instance, we have the current conditions table. Yeah, so that's about that. So let's confirm our progress. So it may take a while for this progress to get featured, but just check to complete, and that means we are done with our tasks. You can also check it here. I confirm your progress. So it should give us a 20 by 20 because I've actually marked it here. So I'm just going to run it again. Yeah, so we have it now. So it's saying please stop your Dataflow job. We've stopped our Dataflow job. So our Dataflow job is stopped like we previously showed. So if you are doubting, let's check once again. Under analytics, Dataflow, then jobs. So you can see the job is cancelled. Yeah, so that's regarding that, and that's probably everything for this lab. So we are done with everything that we need to do. So congratulations for staying till the end with me, and a recap of what we have done. We used our commands to create a new Bigtable instance and table. After that, we now stream data into the table using Dataflow. Then we confirm that the data was successfully streamed into Bigtable by running simple CBT CLI commands to just view five data out of everything in there. And after that, we now use the CLI command also to delete the Bigtable table and the instance in there. So that's pretty much it for now. And this quest, there's still another lab for this quest, which is monitoring and managing Bigtable health and performance, and that's the lab we'll be discussing next. So please, not to miss out, make sure you like this video, subscribe to the channel, comment your thoughts in the comment section, and see you in the next lab. Bye for now.